Okay, this is part 4 of the Chapter 10 lecture notes, and we were talking about chromosomal disorders, particularly if there's non-disjunction that occurs. So non-disjunction means failure to separate during meiosis, failure of chromosomes to separate during meiosis. So if non-disjunction occurs, you're either going to end up with a chromosome missing or an extra chromosome. So in Turner syndrome, we have a missing chromosome from pair 23, which is the sex chromosomes. And a female, and we know that this is a female because there is the presence of the Y is what tells you that it'll be a male. So we know this is going to be a female because she has an X and not a Y, and the O here just stands for nothing. So she literally has a single X sex chromosome instead of two X's. She's going to be short and have a broad chest, widely spaced nipples, and she's going to have normal intelligence, and she'll be fine as long as she has hormone therapy. Now, having children might be hard, and usually is hard for ladies with Turner syndrome, but quality of life can be really good. All right, now there is Klinefelter syndrome, and that's going to be an extra chromosome. So this is a trisomy condition, and it's going to be on the 23rd pair. So the sex chromosomes, instead of having two chromosomes, there will be two X's and a Y. So it's going to be male. So the individual is going to be male because of the presence of the Y. Underdeveloped testes and prostate, some breast overdevelopment, long arms and legs, large hands. Usually intelligence is near normal. And again, it's the presence of the Y chromosome that renders the individual male. However, there's a couple of disorders where the person is chromosomally male or female, but their chromosomes don't match what sex they actually are. So there's a gene on the Y chromosome called the SRY gene, and it seems like even more so than the presence of the Y chromosome is the presence of the SRY gene. So let's say that you have a person who's chromosomally male, has the XY chromosome on the 23rd pair. Chromosomally male. But on that Y chromosome, where there's supposed to be the SRY gene, it's missing. Then that individual is going to develop as a female, even though their chromosomes show male, okay? Because the SRY gene codes for a testis determining factor, and that's going to play a role in the development of the male genitalia. So we really believe it's more the presence of the SRY gene that determines maleness. There's also been XX individuals who are chromosomally female who have the SRY gene by mistake on one of the X chromosomes, and they develop as a male. So those are just kind of special situations. Now, let's look back at the karyotypes for an individual, for a lady that has Turner syndrome. So we look at the 23rd pair. We got all the pairs all the way to 22 that appear normal. There's two copies of each chromosome. But then we get to pair 23 right here, and we have one X and then nothing. So it's a missing chromosome. We don't know if it's a missing X or a missing Y. It's just missing. So there's just one X, and this individual will develop female and will have Turner syndrome. And then for Klinefelter, on the 23rd pair, we'll have an X, and a Y. So there's an extra X chromosome. And this individual will develop male because of the presence of the Y chromosome. Now, other chromosomal abnormalities can come from, instead of like an extra one or a missing entire whole chromosome, we can have chromosome, I can't think of the word, I'm sorry, mutations. Okay, there we go. So a deletion is when one or both ends of a chromosome breaks off. So just a piece of the chromosome is deleted. And then we can also have a duplication where you have a segment of a chromosome that appears twice or more than once. And a translocation is where a segment from one chromosome moves to a whole different chromosome. An inversion is when a piece of a chromosome is removed and then it flips upside down and is placed back where it was. So let's look at some of the syndromes that can come from these types of chromosomal mutations. Deletion syndromes, we just have one example here. It's called Williams syndrome, and it's also known, it's got a French word, cri du chat. I don't know how to pronounce it, but it means cry of the cat. They have a special cry. It sounds a little bit like a cat or a kitten. But Williams syndrome is the loss of the end of chromosome 7, which contains the gene for elastin. Elastin is a protein fiber. So the children have turned up noses, wide mouths, a small chin, and large ears, because you have elastin in your ears and your nose. And I'll show you a picture. This is a picture. All of these children have, and they're precious, but all of these children have Williams syndrome. So that's just a deletion of the end of chromosome 7. And then translocation syndromes, where you have a piece of a chromosome that's translocated, that's removed and then relocated in another chromosome. There's chronic myeloid leukemia, which is a blood cancer, and it's caused by a translocation between chromosome 22 and 9. So it leaves chromosome 22 and moves to chromosome 9. And then there's Alagille syndrome. It's a translocation between chromosome 2 and 20, and it can lead to a congenital heart defect called tetralogy of Fallot. And these are pictures of deletions. You can see here there was an A and it's been removed. Duplications. This is a duplication of segment DE. You see DE twice. Inversion, it was C and then D, and now it's been inverted, D, C. Translocation, this entire piece, just down at the bottom. Oh, I see. Okay, so this is GH and this is QR. So what you end up with is the QR has been translocated with the GH. They've just switched places. And that's, again, that's just a picture of the Williams syndrome that results from a deletion of chromosome 7.